Welcome to Networks Professionals.
You ever just stop and wonder how your phone seems to read your mind? Well, today, we're going to pull back the curtain on the exact technology that makes all of that possible. It's called natural language processing, or NLP for short. And believe me, this science of teaching computers our language, it's changing absolutely everything. I mean, seriously, we kind of take it for granted, don't we? We ask our phones for directions, to translate something real quick, or what the weather's going to be, and they just get it? But how does a machine, a thing built on nothing but pure logic and numbers, really wrap its head around the messy, beautiful, and kind of chaotic thing that is human language? Well, it's not magic, though sometimes it sure feels like it. It's actually a specialized field of artificial intelligence, and it is dedicated to one pretty incredible goal: making computers totally fluent in human. You can think of NLP as the ultimate translator, but not between, say, French and Spanish. No, this is the bridge between us and our machines. It takes our everyday speech, with all of its slang, its context, its hidden meanings, and it somehow transforms all of that into something a computer can actually work with. You know, at its heart, NLP is really a two-way street. It's about teaching computers how to both listen and speak, to understand the words we're saying, and then to generate their own meaningful responses. So this slide does a great job of splitting that mission in two. On the one hand, you have natural language understanding, NLU. That's the machine's reading comprehension. It's all about figuring out your intent, like what did you really mean when you said that? And on the other hand, you've got natural language generation, NLG. That's all about creating a coherent, useful reply. So one side deciphers the what, and the other figures out the how. Okay, so what's actually under the hood here? What's the engine that's driving this whole linguistic revolution? Well, the answer lies in a new generation of incredibly powerful AI models. Now, you've definitely heard of large language models, LMs, like GPT-4. I mean, these are the titans, right? They're trained on huge chunks of the internet, which makes them just astonishingly versatile. But there's also a rising class of small language models, SLMs, which are way more lean and specialized. They're designed to do just one or two things, but to do them exceptionally well, often right there on your phone. It's that classic trade-off. Do you want the massive do-anything power or the nimble, specialized efficiency? But how do these models even know which words are important in a sentence? That's where this really clever trick called the attention mechanism comes into play. Just think of it like a digital highlighter. If you say, I want to book a flight to Paris, the attention mechanism instantly highlights book, flight, and Paris as the most crucial bits of information. It lets the AI focus on what really matters to get the job done. Okay, let's zoom in a little bit deeper. We know the AI reads our words, but you have to remember, computers don't get words. They only understand numbers. So how on earth does that translation actually happen? It's this fascinating three-step dance. First, you have the raw text. Then, the AI acts kind of like a chef, just neatly chopping that sentence into smaller, manageable pieces called tokens. And then, finally, and this is where the real alchemy happens, each one of those tokens gets transformed into a unique numerical fingerprint, a vector that we call an embedding. And this slide really illustrates the concept perfectly. See, an embedding isn't just a random string of numbers. It's more like a coordinate on this huge multidimensional map of meaning. And on this map, words like king and queen are close neighbors. Same for walking and running. This is the fundamental step that lets an AI grasp the relationship between words, not just their definitions. It's a game changer. All right, so we've unpacked the building blocks, right? We've got understanding versus generating, LLMs, tokens, and these incredible maps of meaning. Now, let's connect all those dots and see how these concepts come together in the tools you're probably using every single day. The truth is, NLP is literally everywhere. It's the intelligence behind your voice assistant. It's the magic in Google Translate. It's that helping hand that finishes your emails for you. It's in customer service bots, legal analysis, scientific research, you name it. NLP is probably there, quietly changing how we all interact with information. At the end of the day, all this complex technology really just boils down to one thing: giving machines specific, useful skills with language. So let's take a quick look at a couple of the most powerful ones. First up, sentiment analysis. This is the AI's ability to read, say, a product review or a tweet, and instantly figure out the emotion behind it. Is this person happy? Are they frustrated? Or just neutral? Businesses use this all the time to keep a pulse on what people are really thinking and feeling. And another really powerful skill is named entity recognition. You can think of this one like an AI detective that can scan a long news article and instantly pull out all the key information. The people involved, the places mentioned, the organizations. It's about turning a huge wall of text into a neat, organized database of facts in seconds. And all of this really brings us to the big picture. We are building machines that are becoming fluent in our most human creation, our language. They can understand us, they can talk to us, they can even create with us. So the question really isn't if they can understand anymore. The question is, what are we going to ask them to do next? What new frontiers will we explore now that we have these powerful new partners?
Thanks for watching.